I thought I'd talk today about the way to counter misinformation in maritime informatics. So I've been critical in the past on LinkedIn, maybe some of the videos of initiatives within the informatics spaces that don't have any like measurement basis. So they haven't been measured, evaluated. So I thought in this video, I would actually show how to do that. So that in the future, when people are using VMS systems or different systems, they can actually say, oh, show me the evaluation, show me the benchmarks. Um, this is especially important now when we have artificial intelligence, agentic workflows. So these are um, methods of using non-deterministic in conjunction with deterministic tools to provide a repeatable output. Um, okay, I'll stop there. So what we're looking at here is Marnet. I've talked about it before, and there's actually a website, so marnetproject.eu. I just want to give them credit for this. So they produced this EU-funded Marnet. So 2012 to 2014, they produced it. And what this does, it's a graph and it allows you to route a vessel from point A to point B. You can see right away the fidelity is not very good. Of course, this is a work in progress, I think. And you can use this as a starting point. So, like, you can go here. At Project Harrison, we're creating our own nodal network here in the United States so that we can enhance Marnet. So we can create a more accurate distance from, say, Rotterdam up to, I don't know, Shreveport or something like that, Texas City. But anyone can do this. You can enhance the network and then add your own. In fact, Gent's package allows you to do that. I've talked about it before. Where you can says bring your own network, so you can create your own network and use it here. All right. So, but that's not the point of the video. It's how to benchmark and evaluate systems. So here I did this a while ago. Like, this is just kind of a very loose survey of different ways to get nautical distance. Some of it is very settled, and other parts of it, there's kind of new ways to find distance and to create pathfinding. Um, I see a lot in literature lately the evolutionary method of pathfinding, which seems to be a way of working with complex networks. I'm seeing that a lot in literature, so it seems to be the current sensibility. But I'm just demonstrating this because there's dozens of ways to find like a path from one point to the other. I'm using like pathfinding and things like that. Okay, benchmarking. So I'm going to land on this chart here for a little while, this table. So what I did here is very simple benchmark and evaluation. This is the Oxford definition of what a benchmark is: standard or point of reference against which things may be compared or assessed. That's what a benchmark is. And then the evaluation is making a judgment of other systems against that benchmark. So here we'll use Marnet for an example, and we're going to use two foundation models, the newest foundation models, to compare as well to the benchmark. So the benchmark I'm using, there's many different things you can use, but I'm using the BP distance tables as a benchmark because these were used for many years in shipping offices successfully. Shipping was built on these tables because you can calculate revenue. This all comes down to cost. You can calculate revenue with this. And also, these have been around for so long, and BP's still around, and Nautilus Labs isn't. So you can see that this is a good benchmark. And then I'm using Searoutes as well, which is what we were looking at there. And then I actually just put I prompt engineered an output. I said to chat that give me the distance in nautical miles from, say, New York to Texas City over an ocean going route for merchant vessels, something like that. So I put that prompt in, and then I put in the origin port and the destination port. And this is what I got. So we have the benchmark here, BP distance tables. We have the distance in nautical miles. I should have put that in there. I didn't put it in there, and then I gave four an origin port and a destination port. So the first one is New York, Texas City, and Benawada Matara. Carapito, Venezuela to Gijon, and then Nagoya to Osaka. So interestingly, so we put these in, and so the BP is the benchmark. That's presumably what the correct route is. People can get into like the weeds here about whether it's a rum line or Great Circle track and things like that, but it doesn't matter in this case. We're talking about commercial distances, commercial VMS, and in many cases, even if you're on a ship, generally when you're voyage planning, you don't need the precise distances. When I was a sailor, we had like a master book and it had all the distances. They were rough distances. That's all you needed. You get the voyage orders in. All the shore operator wants to know is like, when are you going to be there? It doesn't take. You don't have to get too finite with the distances to understand that. So Searoutes here, this Searoutes plugged into Searoutes and got a number here. You can see that the fidelity is not perfect. So it's not going to be like a navigator's route, right? It's not going to be perfect. What's interesting to me though is the GPT-5 and how Claude and GPT-5 did it. Down here you have the delta, which is I'm not a statistician, but it's kind of the difference between the two, the benchmark and the actual distance that was come up by each evaluation step. And you can see that actually Searoutes did quite good. Now, this isn't representative. I mean, you'd have to iterate through hundreds of different, open this up, get hundreds or maybe even 1,000 different distances and compare it to Searoute, compare it to GPT, compare it to Claude. But that's not the point. This is just demonstrating like how do you actually evaluate a tool within a reasoning agent. And this is how you do it. So there's a lot of things you can unpack here. You could say if somebody has an AI tool in the VMS, say, you could say, well, where's the data coming from? That's a good question to ask. Well, we don't. Okay. Do you have any? What's your benchmark? What did you use for a benchmark? How did you evaluate your system? What's the delta? And then you can go into all the statistics, which I don't know anything about because I'm not a statistician. But these are the kind of questions you want to ask of any system, whether it's a VMS, whether it's Ectus. Ectus has routes as well. But this is a good step in. And this, again, the whole point of this video is to counter misinformation. Somebody sell you an AI anything, but I think it's good as a customer to ask questions like this. Yeah, I guess I don't have much else to say about this. So I throw this video out and yeah. Okay, take care.